Students, we're going to be looking at something called the law of sines and the law of cosines today. So we had this handout in class in which we talked about how to use SOHCAHTOA to find side lengths and inverse SOHCAHTOA to find angles. So the question is, this only works with right triangles. What do you do with non-right triangles? In other words, we call those oblique triangles. And there's two equations we use with oblique triangles. You can use them with any triangle. They are the law of sines and what's called the law of cosines. The law of sines, the basic idea, you use this when you're dealing with more angles and sides or you're looking for more angles and sides. And the law of cosines is you're working with more sides than angles or you're looking for more sides than angles. Keep this handout right underneath your nose so you have it handy as we do the next several problems. So the law of sines basically says this. Go ahead and draw a triangle up here. We're going to color code it. That's angle A and side A, angle B and side B across from it, angle C and side C. So what this equation is saying is that the sine of this angle over that side is equal to the sine of angle B over its opposite side, which is also equal to the sine of angle C over its opposite side. In other words, the sine of each angle is proportional to the opposite side that is facing. The inverse of the entire of this is also true. You can flip this entire equation with all the sides on top, A, B, and C, and the sines of the angle down below. Let's go ahead and try this particular problem. So we start with a set of sides that is complete with angle and sides. For example, we have angle 105 and side 18. So that's a complete set. We're going to start with that. So the sine of 105 over 18. And then we're being asked to find DF, which is right here. We're going to call that X, and DF, it goes with angle 32, which is across from it. So if we're going to do the angles on top, that's going to be the sine of 32 over X. Same rule applies with SOHCAHTOA. Do not touch your calculator until your variable is isolated. You cross multiply. Okay, X is still not by itself, so we're going to divide by the sine of 105. Keep parentheses around that. So finally we have here that our DF, which is going to be X, is going to equal the sine of 32 times 18 divided by the sine of 105. Now you can get your calculators. Remember, you don't touch a calculator until your variable is by itself. So we're going to do here the sine of 32 times 18 divided by the sine of 105. And we get approximately 9.87, but our instructions say rounding to the nearest tenth, so that would be 9.9. So DF is 9.9. We check for units, no units, so we're just going to write units here. Okay, that's the law of sines. Let's try another one. This time, we're looking for an angle, S. And once again, even though we have more sides than angles, we're looking for an angle. So we're going to use law of sines. So this angle S goes with the 5. So we write sine of angle S, which we don't know, but it's going to go over side 5 equals, now we want to set that we do have, so the sine of 75 over 7. Okay, we cross multiply. Okay, so we have the sine of angle S, that's our variable, times 7 equals sine 75 times 5. So we have inverse angle S equals the sine of 75 times 5 divided by 7. Now, because we have to go backwards to find the angle, first we need to do all of this and get it into a decimal. So this is going to be sine 75 times 5 and divided by 7. And that decimal now, we have 0.6899. And now we're going to do inverse sine to go backwards into the angle. So we do inverse sine, that decimal, 0.6899. And that will get us our angle S. We get approximately 44 degrees. Make sure you get that on your calculator, 44 degrees, which is our answer. Make sure you're getting 44 degrees. Okay, so for this one, we're going to go for NP. Once again, I'm going to color code. We have NP. We're going to call that our X, and that's the angle we're going to work with. So it's sine 88 over X equals, now we need to find a complete match, sine of 39 over its opposite side, which is 22. Cross multiply. Don't touch a calculator until that X is completely isolated. Okay, we're going to divide this out to get X by itself. Alrighty, so we have here the sine of 88 times 22 over the sine of 39 will give us our X, which in this case is NP. Go ahead and try this on your calculators, and I'll work on mine, see if we get the same thing. So try to work ahead of the video, see if you match up. I have sine of 88 times 22 divided by the sine of 39. And I get 34.9, which is exactly what we got earlier. 34.9. So NP equals 34.9. And try one more. We're going to find angle X together. So the sine of angle X over the opposite side it goes with, which is 4.3, equals the sine of 50 over 7.6. Cross multiply, and we get the sine of angle X times 7.6 over 4.3 times, equals the sine of 50 times 4.3. A little ahead of myself here. We're going to divide out by the 7.6. So it's going to be the sine of angle X equals, and you get all of this into a decimal. Take it to the 4th decimal place. So we do the sine of 50 times 4.3 divided by 7.6. And we get 0.4334. And now we do inverse sine. So to find the angle, we have to work backwards. So we use inverse sine, and then that decimal is going to equal our angle theta. So inverse sine, 0.4334, and we get approximately 25.68. which is approximately 26 degrees. Go ahead and take degrees to the nearest whole degree. So that's called the law of sines. We use law of sines when you have more angles and sides or you're looking for more angles and sides. Law of cosines. We use law of cosines when we're dealing with 3 sets of sides or a side angle side. Now this one looks a lot more complicated. Don't freak out. What it is you take any side, and obviously there's 3 variations, but really it's all the same thing. So you start with the side and you square that side. That's going to equal the sum of the squares of the other 2 sides minus this entire entity. You might want to put brackets around this so you see it as a singular entity, minus the same 2 sides multiplied and times 2 times the cosine of the angle opposite the side you're working with. This will make a lot more sense as we work with it. So keep that law of cosines right where you can see it, or you can keep this handout right here handy. Law of cosines. Keep that handout right where you can see it. It'll make a lot more sense as we actually do it. All right, so for example, we want to find DE. So DE, let's go ahead and just call that A. That would make this B and C, and that would make this our angle we're going to work with. Okay, so we have A squared equals, then you do the B and the C, which is simply the other two sides, so 18 squared plus 16 squared minus this entire entity, which is 2 times 18 times 16 times the cosine of the angle opposite of the side that you're working with, which in this case is 21. It's best to do this in two separate entities. So we're going to work this left entity and the right entity separately. So we're going to start with 18 squared plus 16 squared. So we have 18 squared plus 16 squared, and that's 580. Then we have we're going to work right to left. So we're going to start with the cosine of 21 times 16 times 18 times 2. We're going to take that to the second decimal place. That's going to be 537.74. There's a minus sign. We have a squared and equals. So now we go back. 580 minus this. And we get 42.26, so a squared equals 42.26. And of course, the opposite of squaring is square rooting. So our side A, which is technically E to D, which is what we're looking for, is the square root of that. We get 6.5. Which is exactly what we're looking for. That's an example called law of cosines. This will make more sense as we do it a couple more times. All right, so for this one, notice we have nothing but sides. Nothing but sides, and we're going to be working with angle K. So we have to identify which side we're going to put on the left. So 8's going to be on the left-hand side. Why? Because the angle we want is going to be in this position right there. So I'm going to go 8 squared equals, let me color code this for you, 15 squared plus 10 squared minus, I go like this, 2 times 15 times 10 times the cosine of angle K. And angle K is ultimately what we're going for here. Okay, every time you're looking for an angle, keep in mind you're going to be ultimately using the inverse. So just keep in mind at some point we're going to be doing one of these. Inverse cosine decimal will give us the angle theta. So whenever you're looking for an angle, you're going to be using the inverse version or also known as the arc cosine. Alrighty, so let's work this out over here. We know that's 64, 225, 100, and of course this is 300 times cosine k. We have 64, 325 minus 300 cosine k. Our ultimate goal is to isolate this cosine k, but we can't do the 300 first. First we have to get rid of the 325. So we're going to minus 325. That's negative, of course, 261 equals negative 300 times cosine k. Now we're going to get rid of that negative 300. Now we're going to get our decimal. Double negative makes a positive, so we are right here with 261 divided by 300. We get 0.87. Then we use our inverse cosine, that decimal, and round to the nearest whole, which you can see 29.5. We're going to round to 30 degrees. So whenever you're looking for the angle, that's when you use the inverse version. All right, we want y to z here. Y to z, which is right there. Let's just call that x. Well, no, we've got an x there. Okay, we'll just call it x, the variable x. Got it. So we start with our unknown side, which is x squared, equals. We have two additional sides. Big here, so this is 2 times those sides, 4 times 10 times the cosine right here of 34. Work these as two separate entities, so you don't get those confused, two separate entities. 4 times 4 is 16, 10 times 10 is 100, so we have 116 on the left. On the right, we're going to go 2 times 4 times 10 times cosine 34. So we're going to start with cosine 34, working backwards, cosine 34 times 10 times 4 times 2. And we get 66.32. We have x squared. Now we're going to subtract these two. So we have 116 minus 66.32. Of course, we get 49.68. So that's x squared equals 49.68. The opposite of squaring is square rooting. And we get 7.04, 7.04, and we round to our nearest tenths place. Okay, so for this one, we're going to be finding angle R. We have more sides than angles, so we're going to be using law of cosine. So here's angle R, and that's going to go with 9.6. So 9.6 goes on the left of our equal sign. So that's going to be 9.6 squared equals, we get our other two sides, 5.9 squared plus 10.5, 0.5 squared minus, then we have 2 times 5.9 times 10.5 times the cosine of angle R, which is what we're looking for. So remember, the minute you're looking for an angle, keep in mind you're going to be using inverse cosine at some point. Okay, now we're going to do all this math. So we got 9.6 on the left, squared. 92.16. 5.9 squared plus 10.5 squared. I get 145.06. Minus. And then all of this you have to figure out as a single entity right before the cosine R. So 2 times 5.9 times 10.5. And we get 123.9. Times the cosine of R. Okay, our goal is to get the cosine of R by itself, so we're going to start by minusing 145.06. Super important you show your work here so you don't lose track of all these moving pieces. So we're going to get 92.16 minus 145.06. We get 52.9 here on the left. Of course, that's negative 52.9. That's minus 123.9 times the cosine of R. We're trying to get cosine of R by itself. So we divide by negative 123.9, both sides. Double negative makes a positive, so we have 52.9 divided by 123.9. Then we're going to do inverse cosine to that. So 52.9 divided by 123.9. Got that? Okay, now we're going to take the inverse cosine of that answer. Take that to the fourth decimal place. So 4270. So we're going to be doing inverse cosine 0.4270. And round to the nearest whole degree, we get 65 degrees. All right, so here we have the Leaning Tower of Pisa, very famous landmark, and it said it makes a 100-degree angle to the ground, which means it's one of the few buildings that is not at a right angle. Of course, that's not done on purpose. Poor planning in the foundation there. To stabilize a tower, the engineer is considering attaching a cable to the top of the tower that is 40 meters from the base. So we're looking here, 40 meters from the base, and we're asking ourselves two questions. How long would the cable be? So that would be right here. How long would the cable be? That's X. And then at what angle would it make with the ground? So the second question here would be, what's this angle? So we've got two things here. We have a length and an angle. So step one, we're going to work with, you have to ask yourself, do you have more sides than angles or more angles than sides? And technically we have more sides than angles. So we're going to be using the law of cosines here. So this x goes with that 100. So watch what I do here. I'm going to go x squared equals, and I have my two side lengths here, 40 squared plus this right here. Whoops, I meant to switch colors. I'm going to make that green. 56 squared minus 2 times the 40 times the 56 times the cosine 100 degrees. We're going to treat this as two distinct entities here. So we're going to do 40 squared plus 56 squared. And we get 4,736. Minus, now this whole entity here, we're going to work right to left. So I'm going to start with the cosine of 100. And then I'm going to do times 56 times 40 times 2. And notice that is a negative number. That's because our angle is above 90 degrees. So this is negative 777.94. So we have x squared equals, and of course double negative makes a positive there. So I have 777.94 plus 4736. We get 5516.4 square root and we get approximately 74.2 for our length, 74.2. Excuse me, decimal, because of 7 there, it's going to be 0.3. So our length of our cable is 74.3, check for units, meters. Now the second thing we want is an angle. Now, because I now have a complete set of angle with its corresponding sides, I'm going to use the law of sines because that's a little bit easier. So I'm going to do the sine of 100 degrees over that 74.3 equals, and then we want 56 to go with this angle we don't know. So the sine of angle A over 56. We cross multiply and isolate the sine of angle A, which ultimately is going to be a sine of angle A is the sine of 100 times 56 divided by 74.3. I took 2 steps there. We're going to get the decimal of this. So the sine of 100 times 56 divided by 74.3 gets us, oops, I forgot to get the decimal in there, times 56 divided by 74.3. There we go. We're going to take this to the 4th decimal place, 0.7423, and now we do inverse sine. Inverse sine, 0.7423. We're going to round to the nearest whole degree. We get approximately 48 degrees, which would be our angle A right there, 48 degrees. So it is possible to use both law of cosines and law of sines in the same problem. These are 2 very, very powerful equations. Alrighty, you have a couple practice problems to work on your own. Please check your work on the board when you are done.